Why? Answer. Yes, it looks black while burst. Reason. Destructive interference happens. Explanation. Consider a soap bubble. Where sunlight is falling on its membrane, colors are observed due to interference. Constructive interference. 2T equals mx. Where m equals order of bright fringe equals 0, plus or minus 1, plus or minus 2, plus or minus 3. Bright regions are observed. Destructive interference. 2T equals m plus 1 slash 2, x. Where m equals order of fringe equals 0, plus or minus 1, plus or minus 2, plus or minus 3. Dark regions are observed. Burst time. At the burst time, the thickness of the thin film decreases, the path difference becomes half of the wavelength, the light rays destructively meet, hence dark regions is observed. Conclusion. Due to destructive superposition of the light rays, at the bursting moment it looks dark. 2 Quetzales. What is the difference between interference and diffraction? Answer. Yes, there are many differences between interference and diffraction. Interference. 1. Two coherent light waves superimpose. 2. The fringes are equally spaced. 3. At least two coherent sources are must. 4. All bright fringes intensities are same. 5. All dark fringes darkness is same. 6. The zeroth order central maxima intensity always same as that of other bright fringes. Diffraction. 1. The light waves bend at the edges of obstacle or an opening. 2. The fringes are unequally spaced. 3. Only one source of light is needed. 4. All bright fringes intensities are not uniform. 5. All dark fringes darknesses are not same. 6. The central bright fringe is brightest and widest. Summary. The interference and diffraction phenomena are different in many aspects. 3 Quetzales. In Michelson's interferometer, a second glass plate is also used. Why? Answer. Yes, second glass plate is introduced in Michelson's interferometer. Reason. To equalize the retardations of the reflected wave and transmitted wave, or to equalize the traveled path lengths. Explanation. Michelson's interferometer is a device to measure wavelengths of monochromatic lights, extremely small distances, and difference in distances. Second glass plate. It also known as the compensator. Parts of incident ray. The incident ray splits into two parts by amplitude division. 1. Reflected part. 2. Transmitted part. Without compensator. Length of path P1 equals ABCBD. Length of path P2 equals ABCBD. Retardations. Part 1 is retarded thrice. Part 2 is retarded once, therefore. L.O.path P1, L.O.path P2. With compensator. Part 1 is retarded thrice. Part 2 retards also thrice, therefore in the presence of compensator. Second glass plate. L.O.path 1 equals L.O.path 2. Path different equals L.O.P1, L.O.P2. P.D equals ABCBD, ABCBD. P.D equals 0. Special uses of M.I. Detection of gravitational waves. Morley used M, interferometer, and proved non-existence of rather hypothetical medium. Conclusion. The purpose of the second glass plate, compensator, is to equalize the retardations, is to equalize the traveled path lengths. For Quetzales. How you can explain Brewster's law of polarization? Answer. Yes, it's easy to explain Brewster's law of polarization. Reason. The tangents of the incident angle, polarization angle, is equals to ratio of the refractive indexes, i.e. tan empty set equals n2/n1. Explanation. Consider in polarization by reflection process of an incident ray. Apply Snell's law. N1 sin empty set 1 equals N2 sin empty set 2. N1 sin empty set I equals N2 sin empty set R. 1. Angle on a ST line equals empty set I plus 90 degree plus empty set R. 180 degrees equals empty set I plus empty set R plus 90 degree. 180 degree dash 90 degree, empty set I equals empty set R. Empty set R equals 90 degree, empty set I. 2. Plug 2 in 1. N1 sin empty set I equals N2 sin 90 degree, empty set I. N1 sin empty set I equals N2 cos empty set I. N1 sin empty set I slash cos empty set I equals N2. Sin empty set I slash cos empty set I equals N2 slash N1. Tan empty set I equals N2 slash N1. Or tan empty set P equals N2 slash N1. Empty set P equals tan 1 N2 slash N1 1.55. For complete polarization by reflection, the refractive indexes must be known. Examples: glass N2 equals 1.55. Empty set equals tan 1 N2 slash N1. Empty set equals tan 1 1.55 slash 1. Here N1 equals 1 space. N2 equals 1.55. Empty set equals tan 1 1.55. Empty set equals 57 degrees. Example 2. Consider polarization from the surface of water. Here N1 equals 1. N2 equals 1.33. Empty set P equals? Solution. Empty set P equals tan 1 N2 slash N1. Empty set P equals tan 1 1.33 slash 1. Empty set P equals tan 1 1.33. Empty set P equals 53 degrees. What is meant by path difference with reference to the interference of two waves? Answer. The path difference between coherent waves can clearly describe interference of coherent waves. Path difference. The difference in lengths of the paths traveled by two coherent waves. Mathematical form. P.D equals P.D, length of wave 1, P.D, length of wave 2. Two cases of interference. Constructive interference. P.D equals mx, where m equals 0, 1, 2, 3. On this situation of path difference, bright fringes, i.e. maximas, occur. Destructive interference. P.D, sad face, m plus 1 slash 2, x, where m equals 0, 1, 2, 3. In this situation of path difference, dark fringes, i.e. minimas, occur. Conclusion. The difference in lengths of the paths traveled by the coherent waves is termed as P.D. 6 quetzales. Why it is not possible to see interference where the light beams from headlamps of a car overlap? Answer. Yes, it is not possible to see interference when light waves from headlamps of a car overlap. Reason. The light waves from headlamps of a car are not coherent waves. Explanation. Coherent waves from two slits. In Young's double slits experiment, the two waves from the slits coming towards the screen are coherent waves and interference phenomenon occur. Actually, the main source of coherent waves is same. The waves superimposing are monochromatic. Non-coherent waves from headlamps. One headlamp generates its own waves of particular frequency. The other lamp generates waves of different frequency. Different sources of light. The two headlamps are two different sources of light, generating different frequency waves, i.e. non-coherent light waves. Therefore, condition of interference does not follow. Conclusion. The waves from the two headlamps can never overlap to interfere, because the waves are not coherent. 7 quetzales. A telephone pole cast a clear shadow in the light from a distant lamp of a car, and no such effect is noticed from the sound of the horn. Why? Answer. Yes, extremely wonderful thing that light and sound both are wave. The light waves make a clear shadow while the sound waves cannot make shadows of the telephone pole. Reason. 1. Sound waves diffract greatly. BCC wavelengths of sound and size of the pole are comparable. 2. But the light waves diffract slightly on the edges of the pole. The other light waves are completely blocked and causes shadow. In comparison, we can say light waves diffraction is nil as compared to the sound waves. Explanation. Sound waves, horn. The sound waves x equals 17 mm to 17 m, 1. Average size of the pole equals 20 m, 2. Equation, 1 and 2. Wavelengths of sound is almost equal to size of the pole. Hence are comparable and sound waves will diffract greatly and are unable to make shadows. Light waves, headlamp. WVLNGT chess visible light equals 4000 a degree to 7000 a degree. 3. Comparison of equation 2 and 3. WVLNGTH of light, size of the pole. The light waves are only able to do edge diffraction and all other waves are completely blocked, which causes shadow of the pole. Conclusion. The sound waves greatly diffract while light waves only on the edges, hence light waves can, while sound waves cannot generate shadow. 8 Quetzales. Why it is not possible to obtain X-rays diffraction by Young's double slits? Answer. Yes, it is not possible to obtain X-rays diffraction by Young slits. Reason. The X-rays wavelengths are much smaller than slits sizes. XD. Explanation. In Young's double slits experiment, a monochromatic source of light is used. The wavefront is divided into two wavelets by the two slits in the slits board. The two wavelets diffract and interfere on the screen. Here, width of slits less than or equal to of wavelength. Case of X-rays. X-rays WVLNGTH equals 10 superscript 1m equals 1 a degree, 1. Width of the slits is almost equal to 0.28 mm, 2. Comparison of equation 1 and 2. X-rays WVLNGTH, width of slits. Hence, X-rays cannot be used in Young slits to diffract and obtain interference. Conclusion. Common light obey diffraction condition, i.e. d less than or equal to x. But X-rays do not obey the diffraction condition. 9 Quetzales. Can we apply Huygens wave theory principle to the radar waves? Answer. Yes, we can apply this principle equally to the radar waves. Reason. Huygens principle is for the light, i.e. for all the EM waves. Radar waves are also electromagnetic. Explanation. Radar works on radio waves. Propagation of light. Radio waves move in the form of wavefronts. All the points on the primary wavefront are the sources of wavelets. Drawing tangents to all the wavelets, we can get the Toon-Dairy wavefront. Speed of radar waves is 3 times 10m/s. Primary wavefront generate Toon-Dairy wavefront. Secondary generate the tertiary wavefront. The tertiary generate the fourth one. In this way light propagates. The distance of the Toon-Dairy wavefront. It is determined by x equals c increment t. Similarly, all the 7 types of EM waves propagate according to the Huygens principle. Conclusion. It is clear now that radar waves move according to the Huygens principle. 10 Quetzales. How would you justify that light waves are transverse? Answer. Yes, we can justify that light waves are transverse in nature by polarization experiments. Reason. The unpolarized light vibrations are in all directions, and after polarization single-plane vibrations like water particles vibrations remain in light waves. Explanation. Light sources. Bulb, sun, stars, tube light, savers, etc. are sources of transverse unpolarized light. Polarizer / tourmaline crystal, 1. The light waves are allowed to fall on the crystal. 1. The vibrations parallel to the axis of the crystal will pass, while all other vibrations are blocked. Analyzer/tourmaline crystal. 2. Axes of the two are parallel, then the polarized light will pass totally from analyzer, but when you are rotating it WRTTH crystal. 1. The intensity will decrease. Longitudinal waves, mechanical waves. These cannot be polarized like sound waves. Audible, infrasonic, ultrasonic, or supersonic waves cannot be polarized. Conclusion. Thus, transverse nature can be proved by the polarization experiments, where after polarization single-plane vibrations are allowed while all other vibrations are blocked. Blocked.